This video is brought to you by Sporlan. Quality, integrity, and tradition. Today we have a walk-in freezer that's up in temperature, and what's happening is we've got a freeze-up problem. Evaporator's frozen. So we're going to get it defrosted and then proceed from that point. Right now, we're getting our hoses and everything ready, and I'm going to go click it into a defrost while we're doing all of that. So this one's labeled walk-in freezer, and what I'm noticing is when I click it into a defrost, listen. Oh, see, a second ago it clicked right out of a defrost. Let's see if I can get it to do it again. Doesn't look like it's going to do it again, but I think that there might be a problem with the limit switch, because when I turned it, it clicked into defrost and immediately clicked out. So we're going to test it and see what happens. We're going to get it into a defrost, test all the defrost heaters and all that good stuff. I'm going to go ahead and increase the time for now, and I'll make sure I put that back to normal. That way it runs extra long. This is a really old disconnect, and it's a main disconnect with multiple fuses. So this one, everything's been bypassed, so what you got to do is turn it off, and then you got to pull the fuses to do whatever you need to do, but I'm not ready to pull those quite yet. So what I'm doing right now, because we're not done yet, and it's terminating defrost, and I don't want it to. So we're going to verify voltage real quick, and then once we make sure voltage is turned off, then we'll disconnect the X terminal, tape it up, and then turn it back on and let it keep running in a defrost while we're taking everything apart. So I pulled the X, taped it up so I can turn it back on now. So I got it back up and running. It's raining right now, so we need to make sure we put all electrical covers back on so there's no potential of electrical damage because of the water getting in anywhere. I'll leave my stuff over here and here. And I want to point out that this right here, this R12 compressor, is for their walk-in cooler. We are working with the one that has R404A for the walk-in freezer. It is kind of funny though, we still run an R12 one. We still have it out there. And that one still actually has R12. Cross your fingers we haven't had any problems. So we're going to go ahead and click this guy back into defrost. So what we want to do is we want to get back in here, and we want to look at the defrost heaters. So this particular one, this is our heating element wire, and obviously it's going to have an in and an out, right, because the heater is going to have two sides to it, right? So we need to test the amperage on at least one of these two wires going to the drain heater. Then there's another heating element. If you look, these are our elements right here coming through this thing. So that's one heater on the top, and then there's one in the middle. So we just need to get an amp clamp and test amperage. So that's the bottom one. Then that's the middle one. Then I think this is the last one right here. That's the last one. So all three heaters have amperage, which is good. So that means that our defrost heaters are working. So we're going to go ahead and continue to shut everything off and defrost it now with hot water. So the defrost heaters are still running, but you can see we've got a nice freeze up going on. It's a nice tight box, so some pretty good ice stuff going on in here. And then over here, pretty good stuff going on in there too. Custom made sheet metal cover, but we'll get this all defrosted and then figure out why this is all happening and what's going on. So I've started using this wand that I use to clean condenser coils for de-icing walk-in freezers too. And the really cool thing about it is that you can control the flow very easily to full blast, to low, just by simply moving this toggle right here. And you're not holding a thing that you can lose control of like on a normal hose. So I'm finding that that helps, and you can control your flow and not make such a mess with it. So it's working out really nice. And again, I'll link this down in the video show notes. Okay, so we're all defrosted. I did realize that there's another defrost heater there that I didn't realize, so we'll have to check that one too. So there's actually there's a one heater in the top, one heater on the back of the coil in the middle, one heater on the back of the coil on the bottom, and then a drain pan heater. So there's a total of 4 heaters in here. But we got it all defrosted in here. There's a little bit of grease buildup on the back, so we're gonna clean that. And then we got back in the expansion valve section, got it all defrosted in there too. So now we're gonna put it back together and then clean that little bit of grease off the back and then start it up and try to diagnose as to what happened here, if it's just the defrost clock or what. Because I did notice that when I got here, the defrost clock had the wrong time on it. And this thing, they have no ability of turning off the power downstairs. So that defrost clock should have the right time. And it said like 2 p.m. when I got here at 8 a.m. So it's definitely something going on there. So we're definitely going to change the defrost clock, but then we're going to, check everything else out. So we're going to go ahead and replace this defrost clock with the Grassland defrost clock. Now, I go between which ones I use. Sometimes I'll put these in, sometimes I'll put the Grassland in. The reason why I'm putting the Grassland in is because I need a more aggressive defrost strategy, because they constantly keep freezing this box up and we can usually never find anything wrong. Now this time, granted, the defrost time clock had the wrong time, but we're gonna put one that I can put some defrost in the middle of the night. Now, on this one, okay, this is a Paragon. On the Paragon, your defrosts have to be the same all throughout the day, okay? So if I set it to a 28-minute defrost, which is typical, you got to do the same 28-minute defrost every day. Now, what happens if I want to do a 15-minute defrost at 11 and, a 30-minute defrost at 7? That's why I like the Grassland. So I'm not saying I like either better than the other. They both serve a purpose, and in this instance, we're going to use the Grassland. The top snaps in, goes over those holes and into those grooves. Nice and good. Okay, and this is an auto voltage. It's a DTAV, so it's an automatic voltage detection. So we just hook up power. Now, this one, just let's go ahead and hook it up and see what happens. Okay, so we're gonna go ahead and turn on power now that we're done changing the clock. Power's back on. Okay, and we should be running. So what we need to do is go ahead and check our refrigerant pressures. See, we're pulling into a vacuum and we just shut off. One thing we need to worry about is the pressure control setting's a little wonky, because we shouldn't be pulling into a vacuum before it shuts off. But that's not our problem right now. So let's go ahead and this thing should be running. So let's check with the meter. Now remember, 4 and N is our refrigeration circuit, and 3 and N is our defrost circuit. So being that we have a green LED light, and I realize that the camera doesn't show that, but we do have a green LED light, we should be in refrigeration circuit, and the fact that we're not in defrost. So 1 to N gives you what? 0 volts? I'm sorry, you went 4 to N.
Okay, that's 1 to N?
So 1 to N, we've got 208 volts. 4 to N, we have 0 volts. Now what about 3 to N? 3 to N, 0 volts. Now put it in defrost. Just click the pins. Right, look at the triangle. Hold on, something's wonky there. Okay, now click it. Actually, it's, yeah. Check 3 to N.
0 volt.
Oh, well, it's cycling out of defrost because the X terminal's hooked up and it's warm inside that coil.
Oh, okay.
More than likely is what's going on there. But why are we not in refrigeration mode is the question. So check with your meter again. Remember, 1 to N, you should have voltage. 208 volts between 1 to N.
3 to N, nothing. 4 to N, nothing.
4 to N, nothing. Okay. So let's look at your schematic here.
Oh, okay, I know what.
What's going on?
We need a jumper 1 to 2 because there's no jumper here with L.
Show me that on here.
The whole top needs to have a jumper between 1 and 2.
Okay.
But that line doesn't exist here in that car.
That's right. So we're missing our jumper that's acting as our common for the switch leg for the refrigeration circuit. So we need to go ahead and power down, put that jumper between there, and then power it back up. Double checking to make sure voltage is off and that our disconnect switch is working, and it is. You have 0 volts, so you're safe.
Across all terminals.
So you're going to run the jumper from number 1 to number 2, and then now you've powered the common for the refrigeration switch leg. Just because I'm a paranoid weirdo, tighten the terminal for the one we're not using. The F terminal. I just don't like loose screws. It really doesn't do anything and nothing bad's gonna come of it. I just, OCD. Okay, so we're gonna go ahead and turn power back on now. Okay, we're not pumping down anymore. Let's check voltage. So 1 to N. 1 to N gives you 208, okay, or 216. Where are you going now?
We're going to go 2 to 4. I mean, N to 4. 216.
4 to N, 216, that's our refrigeration circuit. Now 3 to N. 0, now put it in defrost and see what happens. Nothing, okay. Because more than likely, we are, the X terminal is getting power. Okay, so if we go between X and 1, you have 215 volts. So that's telling us that you're getting the X terminals preventing us from going into defrost right now. Now let's go ahead and put it into defrost. We pulled the X wire off. And a red light came on and we went into defrost. So we just proved that the X terminal was getting power coming back up and preventing us from defrosting, okay? And our unit's going into pump down right now. And we also need to adjust this low pressure control because if you notice, it's gonna pull into a vacuum right now and we shouldn't be pulling that low. Should be pulling to about 5 PSI and then shutting off. So we made an adjustment on the pressure control. We're gonna see what we cut out at now. And sometimes you gotta make a couple adjustments, so. So it doesn't look like it's the right setup yet. So we'll make another adjustment. Okay, we made another adjustment. We're gonna check the cut-in pressure now. I just slightly cracked the valve so we can see where it turns on. You gotta understand, digital gauges have a lot of latency in them. And, okay, so we cut in about 17 and let's see where we cut out at. 5 PSI. I'd kind of like to see the 17 go a little bit higher, but we're just going to leave it. It's not short cycling, so. Got the unit in defrost, and we're waiting for the coil to be, the unit to pop out of defrost so we can test the fan delay. Okay, so we've got our defrost schedule set up. So we do a typical defrost every 6 hours for a half an hour. Then I threw a couple extra defrosts in the middle of the night just to be safe, and then one in the middle of the day. And this is the cool thing about using the Graslin, is because I can make them do anything that I want them to do. Now, understand that this system is electric defrost, and it's time and or temperature terminated, meaning that we go into the defrost via time, and it can either time out at whatever the setting is. So this one right here is going to be a 30-minute defrost. Each one of those pins is 15-minute increments. Or if the temperature down in the coil gets high enough, the limit switch will terminate the defrost via sending power up on our X terminal. So it's time and or temperature terminated. So the temperature is more or less a fail-safe. So that's pretty much it. We're gonna go ahead and wrap this one up, tell the customer to keep an eye on it. And I also put an arrow on it pointing to this condensing unit over here so we know which one the walk-in freezer is.
Okay, so walk-in freezer that was obviously frozen up and wasn't temping correctly. So we went through and we found, when I first arrived, I noticed that the defrost clock had the incorrect time on it, okay? This particular system, the customer does not have the ability to shut off a breaker, so there's no reason for that time clock to have the incorrect time, okay? Our service company is the only service company that works on this, and we're not over there turning it off. And on the same note, if it was a power related issue, then when I looked at all the other defrost clocks in that same rack, they should have been off the same amount of time, and they weren't, okay? So that indicated to me that more than likely, or that we had a bad defrost clock, but we still went ahead and defrosted it. We changed the defrost clock. We also checked the limit switches, the fan delay, to make sure that the fans were delayed, and we know that the X terminal was working. So we went through the operations of the limit switches. I thought at first maybe there was something wrong, but after testing them, everything was good with the limit switches. There was a lot of grease buildup on the back of that evaporator, which wasn't good. We brought that up to the customer. In general, that evaporator's in really bad shape, and the expansion valve, I believe, is going bad on it. Because it's not evenly feeding the evaporator coil. It's operating, so I wasn't going to replace it at this time. I did bring it to the customer's attention. I'm really trying to get them to replace that equipment because that's a very, very old system, and it's just nickel and diming them basically. So we're in the process of talking about a quote and potentially changing the equipment out, but you know, we'll leave that in their hands. It's working for now and everything else is good. I just want to say thank you guys so very much for taking the time to watch these videos. I really appreciate it. You know, and also too, I want to note that on this one, I had another guy working with me, and you know, I was letting him do some of the work, and I let him make a few mistakes so that way he could learn from them. Okay, so catch you guys on the next one. Okay.